just kind of giving you guys a heads up as to the first examination. I believe that exam 1 is scheduled for not this Wednesday, but the following Wednesday. I believe that's September 21st. All right, so just giving you guys a heads up that 9 days is going to be our first examination. Essentially what I'm planning on doing is, next class we're going to work the majority of the predicates and quantifiers material. Monday next week, we'll probably finish up like a little bit of stuff that we have to do. I'll spend about a half hour for review and answer your guys' questions that you guys might have, and just outline like what to expect to see on the examination.
Just give the exam easier than the homework.
Just make the exam easier than the homework.
11A and B were, I think 11B was quite difficult.
Sorry about that. Not everything can be really easy. Sorry. All right. And what I did was, I think I posted an exam review for you guys, so use that as like a model as to what's going to be on the examination. Those are just old test questions. Okay. So questions before we get started, guys? Everybody okay with what to expect? Okay. All right. So let's go ahead and start by our different number bases. Okay. Generally, there's when we talk about computer science, there's 3 main number bases that we have to be concerned with. Okay. The decimal system is really an imperfect system when it comes to computers because it's not a power of 2. Okay. For some reason, we adopted it as humans because we feel it's the easiest one to utilize. Okay. But basically, guys, in a decimal system, you have digits 0 through 9, so there's 10 digits. Each of the digit places a power of 10. Okay, so you guys can see in the example that I have up here, and also on your guys' worksheet, that if I looked at the number 9,734, you multiply 4 times 10 to the 0, and that's the power. Okay, 7 times 10 squared, because this is the 0, the first, the second, and the third power. So basically, guys, each of the different decimal places or digit places holds a power of 10. Okay. The same thing is true with the binary system, okay? Except there's not digits 0 through 9, there's only digits 0 and 1, okay? So binary just means 2. All right, so basically you guys can kind of think as to why computers work off of base 2. Because if you guys look at it, what's the only things that are in binary, 1 and 0? Well, that's exactly what trues and falses are, right? And that's why we've been doing this Boolean logic stuff, okay? So kind of think of like binary as sort of like the numeric way as computers think. They think of like ons and offs, impulses on and impulses off. Okay. Just like we did with base 10, each of the digit places is multiplied by a power of 2. Okay. So if I had the digit 100010, and I'm looking at this highest 1, this 1 times 32 is why it has a value of 32. Okay. All the other places except for the second place has a power of 0, because every time you multiply that power of 2, it just goes to 0 anyway. Okay? All right. Most people are pretty good with those two, and most people are pretty good with hexadecimal. Okay? Hexadecimal has 16 characters. Okay? They go from 0 to 9, and then they also go from A to F. Okay? In hexadecimal, A is equal to 10, B is equal to 11, C is equal to 12, D is equal to 13, E is equal to 14, and then surprise, F is equal to 15. Okay? So when you guys see those letters, just think of them as representing values for those. Okay? In computer science, we like to chunk things as much as possible. Okay? So think about how tedious it could be to write something like this. Like the number 34 twice. Takes 1, 2, 3, 4, 5, 6 character places. Okay? In base 2, things like 1,000 get really big really quickly. So what we like to do is we like to chunk things into 4 bits. Okay? And that's actually something called juxtaposition, where what we're going to do is we're going to figure out each of the 4 bits at one time and just turn it into hexadecimal. Okay? For those of you guys that are programmers, okay, how many of you guys have ever run a C or C++ program or any program, and it just goes into an infinite loop, and eventually, like you hit like maybe all control delete or whatever, and it says like core dump, and it gives you like this crazy string of like characters. So anybody remember seeing that? That's actually the physical location in memory where it ran out. Okay? Because that's what a core dump is. You just run out of memory, and the computer stops processing. All right? So and you probably see it like says like BEEF 1003 or whatever it is. Okay, That's literally the computer's way of saying, this is where my computer program ended, nothing else I can do. All right, so go there in that physical location in memory, which we can't find, because there's literally trillions of places. Okay, so does everybody understand like how these work and how they're related? Okay, basically, hexadecimal is a convenient way to write binary. Okay, it's just a shorthand way to write it. Okay, decimal is the way that humans interpret numbers for the most part. Okay, so what we want to try to do is, for humans, we want to talk to computers. So for us to talk to computers, we have to convert between these two, and then get into the shorthand way. So I always tell people that, or students, I always tell them, like, if you can get the binary, the other two are easy. Okay, so binary is like your intermediary between the other two. All right, so let's just go through, and the types of questions I'm going to ask you are, I'm going to give you one of the number bases, and I'm going to give you a value, and you guys are going to convert to the other two. Okay, that's basic sort of stuff. Okay, so let's take a look at a couple examples of this. Okay, so I have this value right here. Okay, so 1, 0, 1, 1, 1, 0, 1. And then the subscript 2 means that I'm in base 2, which is binary. Okay? Because if you have a 6-year-old looking at that, or a 7 or 8-year-old, they're going to say, oh, okay, well, that's the number, what, 1,011,101, right? That's what they think. So we don't know if it's going to be in binary or hexadecimal or octal, although nobody uses octal anymore. Okay. All right. So let's say I want to convert this. Okay. Here's the way that I think about it. Okay. I probably should have written this a little bit bigger, but this is just one way to think about it. Okay. So I'm going to write the numbers like a little bit more spaced apart. And what I'm going to do is I'm going to recognize that each of those represents a power of 2. So this is 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 4, 2 5, 2 to the 6. Okay? Because that's what we said binary was, right guys? They're just each different powers of 2. Okay? Anything that has a bit or a digit of 0, I don't care about. Because when you multiply by 0, it's nullified. So this guy, right here, we're just multiplying these. Okay, that's all we're doing. So this is really 1 times 1. This is really 4 times 1. This is 8 times 1, bless you. This is 16 times 1. We skip 32, and this is 64 times 1. Okay? So that's all that really means, guys. We're just adding up the powers and the bases of 2 with this. Okay? Anything that has a 1, anything with a 0, we throw it away. Okay? So this just winds up saying that this is going to be 64 plus 16, which is 80, plus 8, which is 88, plus 4, which is going to be 92, plus 1, which should be 93 in base 10. Okay? And in our class, guys, when we're doing number conversions only, make sure you write which base it's in. Okay? So, now if it's something obvious, I'm okay with that. Like if I say specifically convert to decimal, okay, I get that, okay? But if we don't know, if I'm telling you to convert to 2 different bases, make sure you tell me which one it is, okay? So,
How do you know we're in base 10?
oh, well, what I asked you guys to do first was either convert to either decimal or hexadecimal, right? Anytime you're multiplying by the powers of 2, that's converting to the base of 10. Okay, so now I'll show you how to get to the other one in a moment. Okay, does that make sense, sir?
Yeah.
This is just the process to go to base 10. Okay, other questions, guys? Okay, to be able to go to hexadecimal, let me show you guys how to do that. So I'm going to write the number out again. Okay. And I want you to notice what I'm going to do is I'm going to chunk these into 4s, starting from the right. So basically what I do is I write out the first 1, 2, 3, 4 bits, okay? And then the next 1, 2, 3, 4 bits. Notice that there's only 7 bits. So guys, just like you would do with any other decimal number, what we're going to do is we're just going to put our implicit 0 in front of it. Okay? So this is how we're going to hexadecimal. And guys, doesn't that make sense? Because hexadecimal has 16 characters, right? Well, 16 can be created from any permutation, or the numbers 0 through 15 can be created through any permutation of those values. Okay? Now what I'm going to do is just like we did up top, this is going to be 2 to the 0 plus 2 squared plus 2 to the third. Okay? I don't have 2 to the first because of the 0 in there. So does that make sense, guys? I'm only looking at the bits to where there's a 1. Okay? For the second set, we start back over. So this is 2 to the 0 plus 2 squared. Okay? Because I don't care about the zeros right here. So basically, every group of 4 is its own problem. Okay? Now, if I take 2 cubed plus 2 squared plus 2 to the 0, that's 8 plus 4, which is 12. 12 plus 1 is 13. But we don't want to write 13, right? Because we're going to be in hexadecimal. What are we going to write instead of 13, guys? D, right? And we know it's D because right over here, we said that 13 is represented by D. Okay? So this guy right here corresponds to D. Okay? Does that make sense, guys? We just go through and we chunk 4s. We figure out what the decimal representation is. If it's 10 or over, we just use this table right here. The good news is, this guy right here is going to be 5, right? It's going to be 4 plus 1 is 5. So this guy converts to 5. So our number in hexadecimal is going to be 5D, base 16.
Why is it base 16?
Because this is the process that we use to convert to base 16. Okay? So the first was our process to go to decimal. This is our process to go to hex, because we're chunking in 4s. Okay? And if you think about that, that's like, we can get any permutation of
So I
that.
just want to clarify now, every time we do something, say the procedure in the first step, it's going to be that number to the base 10.
Correct, right. This
We're
is
searching for base 10.
right.
And then
So
the second one we're going to base
right, this guy right here is to convert to decimal all the time, and this is the process
10.
hexadecimal. I probably should have been a little bit more clear about that. I'm sorry, guys.
The only reason is because on binary it specifies binary as base 2.
Oh,
But
okay,
here it doesn't
right.
say decimal system is base 10 or
Right,
hex is
okay.
base 16.
And that's because we started in base 2, so we're converting to
Got it.
base. Okay, Andre, go ahead, sir.
So what's the whole reason for having the letters, the system? Like what's the use for that? Why not just have it with numbers?
Oh, okay. Well, think about this. This is the number 93. Look how long this is. Look how convenient this is. It's much more convenient for us and for computers to start chunking things, okay? Just so that way we don't have like these ridiculously long bits that just take forever to read, okay?
So letters we just chosen because like that's
There's some there.
Convenient,
it's a
right?
solution.
That's exactly right. Okay, go ahead,
What if you get like a number that's like over,
15?
yeah.
Won't happen. That's a good question. In case you didn't hear the young lady, she said, what happens when you get a number over 15 for those 4 blocks?
You always,
What's the biggest possible number we can get? It's 1, 1, 1, 1, right? That's 2 to the 0, 2 to the first, 2 squared, 2 cubed. 8 plus 4 is 12, plus 2 more is 14, plus 1 more is 15. You can't go any higher than that. That's a good question though, because some of us might be thinking, well then we just have overflow, which is why we never have.
so it should be always be under 4 bits, that means.
One more time, sir?
It should always be 4 bits.
Correct. You should never go any more than 4 bits. That's why it's hexadecimal, so we can chunk those and get them into that system. Okay? Does that make sense, guys? All good questions. Thank you. Okay. Let's take a look then at a longer example of this. Okay. By the way, there's no reason as to why there's a space here. I guess when I was doing it, it decided to space out. So let's just go ahead and do that. So 11001. Sorry, it's going to take me a little while to copy it. 11001, 1001, and then 1101. Both ones.
You got one too many zeros.
Oh, shit.
Where I'm beginning. Yeah,
Where I'm done.
very beginning.
11001, 1001, 1101.
That's good.
Yeah, you tripping, bro. Whatever you're smoking, give me some of that.
It's in the car.
It's in the car, nice. Okay. We'll just take a high right after we're done. Okay. So, I guess what we should do is, let's just go ahead and we're gonna convert to decimal first. So remember, with our process for decimal, we just literally write out the powers of 2. 2, 9, 2, 10, 2, 11, 2, 12.
We will need calculator for this.
No calculator, I'm kidding, calculator. The good news is, guys, anything with a 0, just wipe it out like it doesn't even exist. Okay, so the 2 to the first doesn't count, 2 to the 5th, 2 to the 6th, 2 to the 9th, and 2 to the 10th. So, we multiply all those by 1, okay? So this is going to be 1 times 1, which is 1. This is 4, 8, 16. We skip 32, we skip 64. We have 128. We have 256. We skip 512, we skip 1024. We have 2048
and
and
4096.
4896, right?
4096.
4096. Okay? And from there, guys, we just add up the numbers. Okay, does that make sense,
We
guys?
can use calculators in exam, right?
Everyone else can, but you can't.
Oh,
I'm just messing with
so
you.
can I use my smartphone then? I would.
No, sir. I'm just messing with you. Absolutely. Yeah, you guys can use a calculator for the examination, absolutely. Okay? When somebody gets a sum for that, if they'd be so inclined as to tell me what the sum from that is, please. Never. Go ahead, sir.
6,497. I mean, I did it all non-calculated.
Oh, nice.
I might be wrong, but.
That's okay. I could be wrong too. Can anybody verify the young man's suggestion or answer? Not yet. Okay. When somebody verifies that or disputes it, if you guys will let me know. 6546?
6557.
6557?
No, okay.
Well, it has to be odd. It does have to be odd because the last number is odd.
I just did 6,557.
Okay,
Oh,
6557.
yeah, it's 7, I forgot
Okay.
to add the 1.
Okay, that's all right. All right, so we got 2 people that got that, unless you guys are just lying to me and one of you want the problem. Which